Hello, welcome back everyone. I'm Victor, and I'm going to be going through one of the most important concepts in all of algebra, solving equations basically. And we're going to be using the balanced beam model and we're going to help you build a habit that will stay with you throughout year 7 or so, all the way up to like year 12. So think of an equation as like a set of scales. The left hand side and the right hand side are perfectly balanced. You want the scale here to be exactly horizontal, and so as you can see, like the equal sign here is the fulcrum in the middle. Whatever the left side weighs, the right side weighs the same. So today's core habit really is just both sides stay balanced. Whatever you do to one side, you must do the exact same thing to the other side. If you plus 5 here on the left, add 5 to the left, add 5 to the right. If you divide the left by 2, then you do the right by also 2 as well. So this scales must stay level. So let us visit our first equation right here. So what do we have? Let me just check this for a moment. We have x plus 5 equals 13. As you can see in our first example here, let us write that down. X plus 5, which is our left hand side. As you can see, this is on the left, this is on the right. So left hand side, this is on, so 13 right here. So our first equation, x plus 5 equals 13. We need to find, or we want to find x. So that means that we need to get x completely alone on one side. So what is keeping x from being alone? So if you think of being alone, it means like x equals 7, something like that. We want to do something like this. So the plus 5, as you can see right here, is preventing from x being alone. So what we need to do is we need to remove it. So the opposite of adding 5 is subtracting 5. So because we need to have our both sides staying balanced here, if we want to subtract 5 from the left, we need to subtract 5 from the right. So let us do that right now. So I'm going to subtract 5 here on the left. On the right, I'm also going to subtract 5. And let me just delete this. And so what we have is, on the left, x plus 5 minus 5. The plus 5 here will cancel the minus 5. So really we're just left here with x, because x plus 0 is x. On the right, 13 minus 5 is 8. So what we have is 8 right here. And so what we have is x equals 8. This form right here is similar to the forms where x is alone and x is equal to like 6 or something like that. This is what we want. So because we have our very first habit, very good habit, is both sides staying balanced. Our next habit, of course, to help you gain points, of course, is check by substituting back. What we want to do is we want to plug 8 back into the original equation. So the original equation was x plus 5 equals 13, right? So we need to plug x here, so we need to plus it back. What is 8 plus 5? Of course, is going to be 13. So that matches the right hand side, the left part. So we are correct. We never want to skip these 2 steps. Actually, you don't want to skip this step at all, because it takes around like 5 seconds or so, and it catches mistakes that would typically cost you marks in an exam. And so you need those points. You really, really, really do. Okay, so let's go to our next equation. 3x equals 18. So let us just write that down right here. 3x equals 18. Now, what is stopping x from being alone? The multiplication by 3. So as you can see here, the opposite of multiplying by 3, of course, if you multiply by 3, is going to be dividing them by 3. So let's just divide 3 in both sides, because we have our rule here. Both sides stay balanced. Okay, both sides do the same thing. Let's just do that. So we need to divide it by 3 here. and then we're going to divide this by 3 as well. I'm using both annotations. Yeah, it's the same thing. So 3x divided by 3, this is just going to be x. Okay, and then 18 divided by 3 equals 6. So let's just delete everything here, and what we have, 18 by 3 is 6. So x equals 6. We have done our very first step, step 1 here. Now we need to check, we need to do our next habit, which is check by substituting back. So let's substitute back 6 times 3, or 3 times 6, really, sorry. Let me just write that back again. So 3 times 6, 3 times 6 is equal to 18, correct? Yep. Now let's go for another example. This is like a two-step equation here. This is going to be getting a little bit harder, of course. Now let us just write our left-hand side, because this is on the left, this is on the right. So 2x plus 7 equals 15. Now there are two things keeping x from being alone: the plus from 7 here, right here, and the multiplication by 2. Now we deal with them one at a time, of course. Now the rule is undo addition and subtraction first, and then multiplication and division. So we need to get rid of the plus signs of the negative ones first, and then we can think about removing the number that's beside from x. So let's just do that right now. Both sides stay balanced. Step 1, we're going to subtract 7 from both sides. Both sides stay balanced, okay? So let's just minus 7 here, and then minus 7 on both sides. So now what we have, left side, 2x plus 7 minus 7. That's the 7s cancel each other out. So what we have is only 2x left remaining. And so right side, what we have, 15 minus 7, that will give us 8. I'm writing 8 on the left here because I'm going to delete this. Just very simple calculation. And so step 2, divide both sides by 2. Remember, both sides stay balanced, so we're going to divide both sides by 2. So I'm going to write in here both sides by 2, both sides by 2. And so 2x divided by 2 is, of course, x. And then 8 divided by 2 is equals to 4. So let's just delete that, and what we have, x equals 4. Ooh, we have done our first step right here. Both sides stay balanced. We've done this pretty well, but we need to do our very next step. It's so important. It's going to help you not lose marks, basically. So we need to check by substituting back. So our original one was 2x plus 7 equals 15. We need to switch we need to put the 4 into them. Yeah, so 2x plus 4, right, is equals to 8. And then what we have, 8 plus 7 equals to 15. That's our answer right there. So x plus 4 is our answer. So let's go to our next example here. This is going to be pretty difficult. Let's go one more, of course. So what do we have here? 5x plus 2. In our next example, 5x plus 2. This is on the left. What's on the right? 3x plus 10. So let's get rid of the 4 here. 3x plus 10. Okay. This time, you can see that x is on the both sides. What we want to do is our first job is to, of course, collect all the x terms on one side. So we don't want to be having like x on both sides. We just want to have x on one side. So because how do we get x on only one side? So to get rid of this 3x, what we need to do is we need to subtract 3x from both sides. Again, both sides stay balanced. Both sides do the same thing. Let's just do that right now. So 3x plus 10 on the right hand side, or minus 3x. On here, also minus 3x. as well. So let's calculate. On the left, 5x minus 3x this is going to be 2x. It's going to be 2x, of course. 3x minus 3x, that will cancel each other out. And so what we have will be 2x plus 2 equals 10. Now this reverts back into a similar example, into example 3, which you can solve it by yourself, but I'm going to solve it here with you right now. Now again, what we have x on one side here. That's good, and that's great. Now what we're gonna do is that we are going to subtract 2 from both sides, because I want to leave this x completely alone. So let's just minus 2 right there on both sides. Again, both sides stay balanced, and so 2 minus 2 cancels them out. 8 minus 2, this will equal to 8. So what do we have in the left? 2x, right 8. So what we just need to do in the left is divide both sides by 2. Dividing both sides by 2. And what we have here, we have our result here. X divided by 2 will be equal to 4. 2 divided by 2, this will cancel each other out. It won't be 0, it will be 1. Again, in multiplication and division. 2. So what we have is x equals 4. Now what we need to do is we need to substitute them back, of course, because we have done our very first step here. That's nice, but what about our second step? Don't forget this. It's so important. You will lose points if you do not do this. So let's just, we have our, this was our answer right here. X equals 4, so we need to substitute them back. We have on the right hand side 5 multiplied by 4, 5 times 4 plus 2 is going to be equal 22. 3 multiplied by or times 4 times 10 is going to be 12, plus 10 is going to be 22. Okay, so both sides equal 22. This is balanced. This I rushed this just a little bit for you guys. So so we have 5 times 4, 20. 20 plus 2 is 22. So that is how both sides should be balanced. So that is going to be a little bit of a end to this phase of series, just a little bit. I'll be recording more videos, of course, but let's just recap some of the habits that we built across these videos. So again, if we draw a number line, of course, if we draw a number line, and I get this here, this is our number line. Let's expand it a little bit more. In our first lesson, we talked about how left is less, right is more when comparing, and I've showed you a very I would say pretty good habit when you want to visualize. Just when in doubt, just draw it out. Like everything we've done so far has been very visual. With the equations, we have done like an actual scale. With comparing numbers, we actually have a number line, and so forth. And when we want to solve equations, we want to have both sides staying balanced, and when we want to double check, we just check by substituting back for equations, or when we in doubt, just draw them out. These 3 habits are so important that they will carry you through literally every year of high school maths. And so in the next videos, I will be expanding more on these concepts and these habits, and I'll see you there. Thanks for watching.